All right. Hey, how you doing? My name is Charles McNabb. I am in the 2610 section AO2, and this is my Lab 1 presentation on which I chose to do a frequency and thrust correlation, which, of course, I'm going to get into a little bit later. Hold up. There we go. Okay. Quick introduction. So this lab was fun. We were tasked with coming up with our own lab using the LabJack T4 oscilloscope used for the previous lab activities, which we've been doing for what's felt like forever now. A little bit of background here. Over the past few semesters, I've had the opportunity to co-op in airline propulsion engineering, essentially getting really up close and personal with various engine types that this airline utilizes in their fleet. And with that, I've gotten to know a lot of these engines, from small to really, really big, which led me to come up with this experiment where I record frequencies made by various engines and then compare those frequencies which I recorded with their engine thrust ratings. Getting right into how I approached this, again, I was using the LabJack T4's oscilloscope, tough word there, software. The first step that I took was to gather a list of engines of various sizes and thrust ratings. Of course, with my experience, I was able to pull just from what I knew from various airline aircraft engines, and got a wide range there. Then I had to scour the internet, which mostly YouTube, for videos of engines running, which was a little bit easier said than done to find videos that were quality or videos that I would say actually worked for what I was trying to do. However, once I found those videos, I was then able to record their frequencies in hertz at max power, and then just looking to see if I could draw any comparisons between frequency of those engines at max power and their thrust rating. In the end, I was able to find an inverse relationship between max power, frequency, and thrust rating. Essentially, as the engine thrust rating rises, frequency recorded at max power decreases, which is the total opposite of what I thought would happen. My hypothesis was that as thrust rating seen here rose, frequency would rise with it, but that's just not what we saw here. Here also is just a little bit table with some of the engines, frequencies, and thrust ratings, which I worked with, as well as my line of best fit going down here. As you can see, there's a little bit of an inverse relationship there. We are also tasked with just reporting on our progress with our microphone speaker system in terms of the T4. Seen here is my data with the direct to port jack, and then here is my microphone data. Generally, the data was similar from the direct to port to power, or direct to port to my speaker data. However, there are a couple mix-ups here and there, likely just because of extraneous noise, random noise coming through, quality of the microphone, hate to say it, the quality of the equipment we're using, whatever it could be. It's definitely not perfect, but I was able to get it at least some of the best that I could. In conclusion, I was able to find that there is an inverse relationship between an engine's max power frequency and its thrust rating. Now, this data is not entirely perfect, but it is a start. Some possible sources of error coming off of this could be the actual quality of the YouTube videos which I pulled from. They're obviously not all recorded with the same device, recorded from various distances, recorded in different situations, or settings with different echoes and so many different factors which could affect the output that I measured here. So one way to possibly improve this, if one was to go and run with this project, would be to use the same camera and the same environment and at the same distance from the engine and get very similar quality videos. And then from there, they could also expand that to use all different kinds of engines and thrust ratings. But hey, I'm just spitballing here. This concludes my presentation. Thanks for watching.